Cisco Certified Network Associate Day 53. Welcome back everyone, I'm Imran Rafai, your trainer for this entire series. Like you watched our last video, we would be using the next few videos, including this one, to upgrade our series from the old series to the latest Ccna 200-301. Right? So if you're joining us for the first time in this video, I would recommend that you go back to our day 1 video. So if you go to our playlist, the entire playlist with all our videos is going to be there, and you can start from day 1 and progress and reach day 53. That way you will be in sync with what we discuss, because some of the topics that we might discuss, we might skip through some topic because we have already discussed, right? So if you're joining us for the first time, day 1 is where you should be starting. For all those people who have progressed with us and reached here, then you can continue with this video. So without wasting much time, let's get straight into today's class. And like always, before we go ahead, please click on that subscribe button, and after you click on that subscribe button, click on the bell icon. So when you click on the bell icon, you would have to click on all. So what happens is anytime we add a new video, you will be notified. And of course, also please click on that like button. Our social media contacts on the screen. So on the left side are our company contacts. On the right is my personal contact, and my email address is as given on the screen. Many videos ago, we discussed about the network fundamentals. That's in day 1, and we showed you this picture. All right, this is we showed you this picture, and we showed how different components of the network were, but we didn't really go in depth because it was the first video in the series. But I think today is the day we'll go into these network components and discuss most of the things here. You would know, like the switch, you know what a switch does, you know what a router does. All right, so maybe we'll discuss a few other topics that you don't know, and let's fill the gap. So let's take these two client computers, right? So if these two computers need to share data or share resources or share files, we need to have some way to connect these two devices together. So one of the most common ways that we do is we make use of the Ethernet port, right? And then we use a Cat5 cable and connect these two devices. So once these two computers are connected, this forms the very basic networking. So once these computers are connected, you can share data, share files, share resources, whatnot, right? So this forms a basic network. Now, you hear the term client and server, right? But one thing we need to understand is client and server has nothing to do with the device. That means any of these devices that you see here can act like a server, right? You could maybe have your iPhone act like a server for whatever reason. You might need to act like a web server to do something. So you can you can run a web server program on your Android phone or your iPhone, and all the other devices can connect. So once they connect to your phone, and if your phone is serving the website, then the phone becomes the web server, right? So what I'm trying to tell you here is client and server has nothing to do with the hardware. Client and server is more of a function. So if you configure a laptop to be a web server, then that is a server, right? Ideally, in a production environment, of course, the server is going to be a very high-end computer, right? But again, it is just a regular computer. It is a server because it is running a function to be a server, right? So we have different types of servers. It could be a web server, it could be file server, it could be database server, it could be any server. But again, it all depends on how it's configured, and it's more of a software thing. Typically, when you read Cisco documents or any technical documents, you would see icons like the one that you see on the left, right? So for a switch, a layer 2 switch, you would see this. For a router, you would see a round device like this, and if it's for a layer 3 switch, you would see a device like this. But for purely aesthetic purpose, I'm going to use icons that you see on the right, right? So this is something that I'm trying to build. So I'm going to make these icons ready. So I will try using these types of icons. So whenever you see these icons, you will know what it means, right? And of course, it doesn't matter what icons, these are just for your logical diagrams. But what I'm going to do is at the end of this video, I'm going to show some of those devices. So if it's an L2 switch, I will show how a physical switch looks like, right? If it's a router, how does it look? And if it's like any of these switches, I'm gonna show physical pictures, right? Real pictures of those physical devices. But for the purpose of this video and many more videos in the series, we will be using the icons seen on the right. So we would be using, for layer 2 switch, we would use this, for router we'll use this, and for layer 3 switch we'll use this. But again, we could, I mean, even if we use this, you know the difference. And mostly if you're looking at Cisco documents, these are the icons that Cisco and other technical documents use. So let's create a small network. So let's take these 6 devices. So if I have to connect, of course, like we discussed, we could connect by wire between these 2 devices. So if I want to connect, I could take a wire and connect these 2. That's a LAN. I mean, it's a network. But a more practical way to connect is by using a network device like a switch, right? So what you do is, once you have a central device like a switch, you could take a cable from this device and plug it to one of the ports, and again from the other device I can take another cable and plug it to the next available port, right? So don't worry about the wires mixing. So actually it is 2 different ports. Laptops and mobile phones, ideally, I mean, like you see here, I have connected it by wire, but ideally these are the devices that is meant for connecting wirelessly. I mean, these are devices that you wouldn't typically see plugged in. I mean, you could plug in, but it would be better if you could get it to connect wirelessly, right? So we could make use of another device like an access point, right? You could use an access point. So you could connect a cable from the switch, from a free port in your switch, and connect an access point. And once you connect an access point, of course, all these devices, using the power of Wi-Fi, it can connect with each other. Mobile phones can connect, your laptop can connect, all devices that can support Wi-Fi can connect to the access point. So again, now, just because it's connecting through Wi-Fi, it doesn't have any less feature or more feature than maybe say this computer or this laptop that is connected through wire. So wireless or Wi-Fi is nothing but a replacement for the wire, right? So of course the speeds on a wire is going to be slightly better than the speeds on Wi-Fi, but with new advancements in Wi-Fi technologies like the Wi-Fi 6 that just recently come out, the speed difference is completely becoming irrelevant. So now let's expand this a little more. Let's assume you are an administrator, and let's assume this is the admin computer, right? So this is the admin computer, this is where you sit, and let's say you have 3 floors. So this is the ground floor, or like in America you call it floor 1, and then this is floor 2, and this is floor 3. And let's say each of those floors, except for the first floor, you have 1 Wi-Fi device. In floor 2, you have 3 Wi-Fi devices, and then floor 3, you have 3 Wi-Fi devices. And of course, you have different users. So maybe there's another laptop here, and they are connected. There's another laptop, right? And they're connected. So every floor, there are users. So you put wireless access points, and brilliant, everything is working. One fine day you realize that this password, so to make it easy, what you do is, you typically, when you configure these access points, you would put one SSID. So again, okay, let's talk about this. When you go to your laptop and you want to connect to this access point, what you search, right? When you search and you get that name is called the SSID. Right? So once you click on that SSID, it would ask for a password, and depending on how you're configured, you could put a password and it will connect, right? So normally in a small office, to make it easy for the administrator, they generally put the same SSID in all the devices and the same password, right? Now think about a scenario. Now wireless being wireless, even your neighbor will have access to it. So your neighbor will also have access to the SSID signals. Of course, if it's not designed, if your network is not designed well, and if your wireless access points are positioned in a place and the power output is not controlled so as to not allow a lot of power to go outside the building. So if at all it's going outside the building, and let's assume a neighbor of yours has access to the username and password, or rather SSID and password. Now, how do you prevent that? So in a typical access point, the access point that you have in your house, if you want to change username and password, you have to either physically go to that device and plug a cable and then make changes, or you have to use the IP address, connect to that device and make changes, right? So in this case, you have 7 devices, slightly more work, but still, if you're really determined, you can go to log into each of those devices and update the password. After 1 month, if again the password is compromised, you could again do that. But what if your company has 100 wireless access points? Are you going to go to 100 devices or log into 100 devices and make those changes? I don't think so. So to overcome that, we have another device called the wireless controller. So what does a wireless controller do? So first we need to connect this wireless controller. So from our switch, let's take one more cable and plug the wireless controller. Now the admin can connect to this wireless controller, and then from there he or she could just change password and say apply, and automatically it sends a command to all the access points which would immediately change the password. It's easy, isn't it? That's a beautiful way to change access points. So whether you have hundreds or thousands of access points, you could just manage all of them from one place, and just by hitting one button, all the passwords will get updated immediately. Now, that's brilliant. Now, come to think of it, many videos ago, we also discussed passwords for the switch. If you remember, enable password, telnet passwords, console passwords. If your company has hundreds of these switches, right, and if you have to change the password for hundreds of those switches, how would you do? With the knowledge that we have now, you would say that we'll telnet into each of those devices and change the password. Again, Cisco has thought about it. Cisco has released a new device called the Cisco DNA Center. So again, DNA Center is connected the same way. So from your switch, you take a cable and plug the DNA Center. And of course, the admin can log into the DNA Center, and the DNA Center has access to, I think this cable needs to be plugged in here. So the DNA Center has access to all the devices. So if you connected to all your switches, your DNA Center can become a central monitoring, central design. So DNA Center, you can do a lot of things. You can design your network, you can monitor your network. So if there's any problem that's happening, you can actually get messages saying how this. You can even automate things. There are a lot of things that Cisco DNA can do, right? So Cisco DNA is again a controller that is used to manage switches, manage the wireless controller. So DNA Center can talk to your wireless controller, and in turn, the wireless controller can communicate with all the access points, right? So DNA Center you can configure switches, you can configure routers, and you can configure wireless access points through the wireless controller. Again, if some of you who's had some experience would say, Imran, this is not how you connect switches. Of course, this is not how you connect switches. You would never have layer 2 switches looped in like this. Typically, you would have 2-tie architecture or 3-tie architecture. Again, we'll talk about the 2-tie and 3-tie architecture in the next video. But here, I'm just trying to show the concept. That's why I've just looped in. And in a small office, this type of configuration might work, right? So once you have devices like this, what would you do? Now, if you want to go to the internet, we introduced another device called the firewall. What's a firewall? We'll come back to it in a minute. After the firewall, we could have a router, and router to the switch. So again, if you were to connect it, so from the switch, I could loop in the firewall. From the firewall, I would connect to one of the ports of the router, and from the other port of the router, I connect to the internet, right? So now all these devices in the network can, through the firewall, access the router, and from the router to the internet. Let's zoom in a bit. Let's take these two computers. Again, we'll put a switch. So if these two computers had to connect to the switch, I would take a cable like earlier and plug it. From this device as well, I will plug it, right? Now from here, again, like I said, firewall. From firewall to the router, from the router to the internet. Now, what's a firewall? A firewall has got a very basic principle, right? So firewall, when you configure a firewall, you would say which is your internal interface. Let's say if this firewall has two interfaces, one will be internal interface, where you would say it's a security zone of 100. So you've got a security level 100, which means it's very secure. And your public facing interface, you would give a security level of 0. So firewall works with the basic principle which says any traffic coming from a low security level to a high security level has to be dropped. Any traffic going from a high security level to a low security level can go through, right? So if this device wants to communicate with somebody on the internet, that traffic will go through. But if there was somebody on the internet who would want to, let's say, attack this device, when that traffic hits the firewall, firewall say you're coming from a low security level to high security level, that is immediately blocked. But you might have some genuine cases where, for instance, this is, let's assume this is a web server. Again, this is not how you would configure a web server. Typically on a web server, you would put another zone and let's say they have another interface, and that zone you would put a security level of 50. This is called, typically this would be the DMZ zone, demilitarized zone, that's DMZ. And then you would put a web server there. So even if you give access to that zone, they would not in turn start an attack from your web server to your internal network, right? That's why you put it in a DMZ zone. But again, just for the purpose of this video, just to prove a point, I just want to say that if you were to give access to the web server, you would go into your firewall and open a port because web server works on, HTTP works on port 80. You would say any traffic coming in from low security zone to high security zone, for port 80, that's a web server, please let it go through, right? This is something that you would have to go through. So you sometimes call it as opening the firewall, right? You're opening a port in the firewall. But the problem, like I said, is if at all somebody with the right tools get access to your web server, they could in turn launch an attack from your web server to all your devices in the network. Because it's a local network, it's going to be really difficult to mitigate. I'm not saying it's difficult, I'm not saying it's impossible, but again, without the right tools and right devices and right appliances, that could be a problem. So how do we mitigate? Let's say there is somebody who's trying to access from outside, he's trying to intrude. So in this case, let's say if there's a web server and then already you have opened the open port 80 for the web server traffic, what do we need to do to prevent an intrusion? Let's say somebody's come here and then he's trying to attack all the other computers from here. He's trying to intrude. What can we do? There is a device called, there are two types of devices. One is an IDS, that's intrusion detection system, and there is another device called the intrusion prevention system. So if it's an IDS mode, so let's connect this to this, and let's say this is the IDS mode now. So if it's an IDS mode, what happens is, let's say we are looking at traffic on this port, right? On this port, so any traffic coming here, it will constantly start getting a packet. So as an administrator, you will have to create a span, which means any traffic coming to this port, you would send a copy here automatically, right? And this will analyze that traffic, right? IDS will analyze that traffic, and it sees that there is some intrusion that is being, like somebody's trying to intrude on whatever malicious packets being sent. The IDS will immediately realize that there is an intrusion, and since this is an IDS, it can only detect. So what you could do is you could configure it to, if this is the admin computer, you could ask it to send a notification to the administrator immediately, right? That's what an IDS can do, because it's not in line. But if, let's say, the firewall is not connected like this, let's say I'll remove this cable, and let's say now the firewall is connected from this device, right? Now this is in line. So now same guy, again, somebody, let's say we'll call it the villain with with two horns. So let's say this bad guy, he's again trying to intrude, but now since the traffic is going through the IPS, and when the IPS detects it, so this is the IPS intrusion prevention system. Now again, just like IDS, it detects that there is intrusion, but since now traffic has to go through the device, immediately the IPS can drop that connection and drop that packet, and hence this guy cannot get access to our device or to our network. So this is what IDS and IPS is. Now there are two types of firewall. Again, we'll not get too much into firewall topics because we'll be coming back to a lot more about firewall when we start our security topics, but now this is just basics of firewall. So typically the firewall that we explained here is what we call the classic firewall, and Cisco has got a classic firewall like the Cisco ASA. So in the new firewall, so what we call the NG FW, the next generation firewall, so you will hear people say NGFW, so that is next generation firewall. So next generation firewall is a lot more complex firewall. So typically this IPS is inbuilt in a firewall, so you have the firewall functionalities, you have IPS inbuilt. Other than that, it has a lot more features, including threat intelligence. Like Cisco has a network of engineers who are all the time monitoring threats happening around the world, and as soon as it realizes there is a threat happening in one part of the world, it can start sending those updates to your devices and to all the devices of Cisco, all the next generation firewalls. So immediately those threats and intrusions are updated, so everybody who using the Cisco NGFW are protected, right? So it has this advanced threat intelligence that is received from Cisco, which makes sure your network is completely protected. And I mean, these devices, let's say for instance devices like your laptops, your phones, these are all called as endpoints, and typically in a network these endpoints are your weakest links, right? Whether your phone, whether your laptop, these are your weakest links. So again, like I said, once we talk about security, we will talk a lot more about preventions and security and all that aspects. And now let's assume this device, let's say it's on VLAN 10, and let's assume this web server is on VLAN 20, right? So now if VLAN 10 device wants to access the web server, the traffic would come to the switch, and since they are in two different VLANs, of course the switch cannot send traffic to each other's ports. So what we would do is, if you have been following with us till here, from day one, you would have gone through a concept called router on a stick, right? So now the switch will have to send this device through the IPS, through the firewall to the router, and router being the router on a stick, it will get the traffic here and then send the traffic back on the VLAN 20 interface. Or rather, what happens is, if you remember, we do sub interfaces, right? So one sub interface would be doing VLAN 10, the other would do VLAN 20. So it would take traffic from VLAN 10 and put it on VLAN 20. It will come back the same path, and then it will go to the web server. But this is not, I mean, route on a stick is a workaround. There are better ways to do it, and the better way is to upgrade your switch from a layer 2 switch to a layer 3 switch. So layer 3 switch, what happens is then the traffic can come to this port, and since layer 3 switch can do routing, layer 3, right? It can look at layer 3 protocols and layer 3 packets. It can do routing and it can send traffic from here to here. It can, without having to send the traffic to the router, layer 3 switch can do inter-VLAN routing, right? So that is another use. That is the use of layer 3 switch. So like I said, we used the icon, so I want to show you how these switches look. So this is how a layer 2 switch looks. This is the 2960 series. This is the layer 3 switch. This is a 9600 series layer 3 switch. This is a 1900 series Cisco router. And this is the wireless controller, 5508 wireless controller. This is a DNA Center. This is a DNA Center appliances, by the way. DNA Center, of course, has virtualized appliances as well, but this is the physical appliance. This is the classic firewall, like we were speaking, ASA 5510 classic firewall. So, like I said, this video and the next 3 or 4 videos are all going to be bridging videos to ensure that we have updated our series to reach the latest Cisco CCNA. So if you have any doubts, like always, please feel free to comment here. We will try and answer your queries. If not, I'm sure a lot of your fellow learners will be able to answer your queries. So thank you for joining me today, and we'll be back very, very soon. Bye-bye.